Here I have some hint for your homework 3 for chapter 3. So first problem, try to find Fourier series for a given signal. So here if you look at xt, right, there's two triangle waves. So first of all, we find the period. The period is here to here, so period is 2. So omega 0, 2 pi over t, we get pi, just as we did in our examples. So now we use equation. A0 is 1 over t, right? Here is the integral of entire t, 0 to 2 xt. There is no complex exponential for xt. So dt. Then we know this is my xt, right, in one period. So we know the slope is 2, right? Slope is 2. And here, when t is 0, there is 2. So we have 2t minus 2. Calculate the integral. Now I change my duration from 1 to 2, because only from 1 to 2 it does have value. Okay. So the integral of 2t minus 2, we have t squared minus 2t, two boundaries, and we get a0 is half. Now we calculate ak and bk, so they're similar. So for ak, everything's the same except we have cosine pi kt involved with the integral. Now we have 2t minus 2. Here is the integral of cosine, we get minus sine, right? So we have the boundary substitute in it. And here we use the integral equation, and this is the final answer. You can get this one from the table. So cosine pi k, right, when k is different value, we have different result for cosine pi k. So when k is even number, cosine 0, right, cosine 2 pi, cosine 4 pi, we get 0. When k is odd, like 1, 3, 4, 5, cosine pi k is 1, right? So here is our final answer for AK. For BK, instead of using cosine, we have sine pi kt over here. So all other stuff are similar. I'm going to show this detailed step by step in a file and upload to Blackboard, so you can take a look. So now I get a0, ak, and bk. So you can express xt in this synthesis equation, right? So xt is a0 plus summation of many ak's times cosine harmonics, and many bk's with those sine harmonics. So this is a hint for problem number 1 in your homework. For other problems in your homework, you can use similar procedure. So step 1, find t and omega 0. Then use equation, find a0, ak, then bk. You may want to use integral table. It's available in Blackboard. Okay, problem number 2 in your homework. So I just use this one as example, give you some hint. The real problem is similar, but not the same. So if xt is sine t plus cosine t, try to find the Fourier series. So this time we don't use previous integral method, we use inspection method. So by using Euler equation, we have sine t expressed by 1 over 2j ejt minus e2 minus jt. Cosine is half ejt plus e2 minus jt. So sine, cosine expressed in terms of complex exponentials in a combination. So now you look at this one, right? So ejt, anything before it will be the coefficient c1, right? So here we have 1 over 2j and half. So combine those two together, we get c1 is half plus 1 over 2j. same thing. So here, E minus E2 minus JT, right? E2 minus JT. So combine those two, we get C minus 1. So here C minus 1. All other coefficients, they are 0. So we call this method inspection. So number 1 is from definition. Number 2 is inspection method. Okay, number 3, based on the property of Fourier series, we can solve some problems. So here is a hint for you. So if we know xt is linear combination of many harmonics, so we call ck complex coefficient, right, for xk. So this is your Fourier series. Now we have a new signal. Okay, this new signal in your homework problem is part C. So Vt is xt times something. Now we want to find Vt's Fourier series by observing xt's expression. So let me show you what to do. Okay, so here we write Vt. Okay, Vt is ck e 2 minus jk omega 0 t. What is this one? This is xt, right? Xt. Okay, here xt times ej 2 pi over t. So this is in your condition. Now we combine those two together. Remember, 2 pi over t is omega 0 as well. So here we combine them together. We have ck ejk plus 1 omega 0 t. Now I'm going to do, the tricky thing is here. Now let n equals to k plus 1. So we rewrite the previous step into next step. So now we have n, right? N and c n minus 1. Right, so ck change into n minus 1. Here we have ejn omega 0 t. So what does this mean? So it means now Cn minus 1 is this signal Vt's Fourier series. So we can write down Cvn is Cxk minus 1. So this is problem number 3, right, in your homework. Next one, I just show you a hint. So there is a problem, right, in the question. We have a signal xt. So if you look at this one, xt is a linear combination of two parts. One part is a rectangular signal and plus a triangle signal. So xt is 1 plus another one. Find this each individual one's Fourier transform. Then use linearity find out the original one's Fourier transform. And both rectangular function and triangle function, you can find their Fourier transform in the table. Okay, next one. Okay, next one, I just choose one problem in 3.25, show you some hint. So we know for the signal, it does have Fourier transform 1 over j omega plus b. So this is a pair, right, in your table. Now I have a new signal. The new signal is a modified version of xt, right? So if Vt is t squared times xt, we can use one property in Fourier transform, that is time by t to something, right? And in Fourier we have differentiation for x omega. So we use that property. Now the new signal's Fourier transform is d squared d omega square, and x omega, right, goes over here. So we calculate the 2 times of differentiation of x omega. This is the final answer, and here is the procedure. here is the procedure. You can take a look. I'm going to upload this file into Blackboard, so please take a look. The last one, we talk about real, even, symmetric for Fourier transform. So if xt is real, we can obtain that. So for real signals Fourier transform, magnitude even symmetric, phase response odd symmetric. And we also know if x omega is real, if your Fourier transform is real, is real function, your original signal is even symmetric. Once your Fourier transform is imaginary, your signal in time domain is odd. So let's look at one problem. Okay, over here, so we have x omega, right? A Fourier transform is given. If you look at this one, x omega is real, right? If f omega is real, we know original signal xt is even symmetric. And Fourier transform is even symmetric, right? Even symmetric. So that tells us xt is real. So combine those two, we get xt is even and real signal. So here, right, xt is real and even signal. Okay, so we know x omega, this is definition of x omega. This is definition of inverse Fourier transform. So x0 is, we change t to 0 here, right? So here in this equation, t goes to 0. ej omega 0 is 1, right? So x0 is just integral the entire x omega. So what is my x omega? X omega is here, right? It's here. So find integral of this one. We can find x0. So x0 is 2 pi, 1 over 2 pi, right? Minus 1 to 1. Minus 1 to 1. 1 d omega. We get x0 is 1 over pi. So instead of calculate the inverse transform, you can find some important values in xt by just using the Fourier transform properties.